maybe let me tell you a little bit about Replique and what we are doing before starting the actual webinar. So Replique is an end-to-end 3D printing platform that enables OEMs to store their parts digitally and get them produced anywhere worldwide in the right time, at the right place, and in the right quality. And we are basically helping our customers in any step of their 3D printing journey, from qualification to on-demand production and even shipment of the parts. Arash Rashidi, who will host this webinar today, is our technical sales expert. So he's responsible for the customer relations, and he supports our customers in these steps. So he helps our customers to find the right parts for 3D printing, but he also helps them in implementing our software into their business processes. Shashidi has a PhD in physical chemistry, and he has worked over 10 years now within 3D printing industries. And with his experience in materials and also in 3D printing application, he's the right guy and knows exactly for which parts the technology makes sense and for which parts the technology shows huge advantages. So with this, welcome Arash, and the floor is yours.
So thank you, Melina, for the nice introduction. Good afternoon, ladies and gentlemen. Welcome to our webinar. I will talk in the next half an hour on the about identifying suitable parts for 3D printing. Just some words to the goal of this webinar. What do we want to achieve at the end of the day? So I will talk a little bit about the economic side of 3D printing to understand it better. How can 3D printing help us with more innovation, reducing the fixed costs, for example, molds, or other aspects like the advantages of 3D printing regarding minimum order quantity, so you can practically produce from the stock number of one, and also how 3D printing helps reduce the delivery time or be faster in the market. We will also take a look at the, let's say, from the part and design part of the topic to see which parts benefit most from 3D printing. And we will show you different real use case parts and examples on this topic. So the question that starts always is, when is 3D printing a good alternative to traditional manufacturing? So to answer this question, you can have a look at it from two different aspects. One is the supply chain aspect, and the other is the design aspect. So from supply chain, 3D printing is a good alternative to other manufacturing methods when your parts require short lead time. So you have to have the parts as fast as possible. If the parts are required discontinuously, so like the topic of spare parts. Of course, if you are producing in different locations, is also 3D printing a good choice for the production. And of course, if so you are in a medium or low volume series production. On the other side, from the design aspect, there are so different parts that are very advantageous to be 3D printed. So if you have assemblies that can be printed in one part, so this so-called all-in-one part manufacturing. Of course, lightweight is a very important topic that you can address it via 3D printing. Customization is another aspect, and of course, using the design freedom of 3D printing to produce complex parts. Of course, if you are using 3D printing, or you are going to use 3D printing, there are certain challenges that you have also to take into consideration. Size is a topic that generally you have to pay attention to the fact that So there are certain geometrical limitation in 3D printing based on which material or which technology combination are you using. On the material side is also the challenges there that, of course, the mainstream polymers and metals are almost all available and easily available. But if you are going to the niche or exotic materials, then so the availability of these materials for additive manufacturing is more restricted. The other topic is also the certification for the application of the materials that still many materials do not have the required certification from industry and because either there's not enough data already or it is still in the standardization process. So, but the good news is that additive manufacturing is a very fast industry and everything changes, let's say, day by day. So many of, for example, limitations on size and materials change daily, new technologies, new materials available. So then let us go back again to the aspect of the supply chain for 3D printing and talk a little bit more with real examples from industry to see, okay, how can 3D printing help us in different aspects. So as I already mentioned, additive manufacturing is a choice if you have parts that are required discontinuously or unplanned. So it's more like topic of spare parts. So as you can see here, for example, we have a customer, Sienna Garden, which is a manufacturer of outdoor furnitures, and they have introduced the topic of eternal spare parts. So the spare parts for outdoor furniture are then printed and is available anytime for the customer. So here you can see, for example, some holders of the chairs for garden chairs. So this is also helps the companies to get less dependency to their suppliers, because as soon as you have the 3D model and the manufacturing file for your printer, it's only necessary to choose one of the many, let's say, print farms or service providers that are around that have the correct material, and then you can directly print your part. And of course, very important is that there is no minimum lot size. So as soon as the customer orders, you can print the parts. The second topic is, of course, production in multi-locations. The good news is that if you have the same printer, same material, and same production part, you can have your parts produced at different locations in a replicable way. So, and this minimizes the shipping times, of course, costs for shipping, for transport, all the logistic costs, and of course, it is also helps sustainability, and these are the very important facts for the 3D printing in or production in different locations. And the other thing is that, of course, you can with one printer you can have so different types of products, so you don't need different machines to produce different parts, and also you don't need to have molds and profiles and for the extrusion profiles, all these in any specific production plant, and which then reduces dramatically your costs. Of course, 3D printing is very interesting if you need products with short lead times. So the products can be produced on demand and the location close to the end user, which dramatically reduces the transportation time. And if you have very critical spare parts, this plays a very important role, because time is then money for you, and if you stop your machines or your production, then you lose money. So short lead time plays a crucial role here. So here we have, for example, with one of our customers, Granite, that are producing spare parts for the transportation industry, and so they can have the parts ready in a very short time, and they don't need to have molds and production so production parts there, so they can just directly print and make also their inventory shorter. So if you need parts that are just needed in medium or low volume, then 3D printing is a very good option for you. It is because, for example, one of our customers, Alstom, introduced 3D printing to produce cost-efficient small batch production for their trains. And because here 3D printing doesn't require high investment or fixed cost for toolings, and so it makes suitable for production parts from one single part up to medium volume. Of course, you can always produce one single part, but in different 3D printing technologies, it's maybe more suitable to produce in batch sizes to fill the, let's say, print box of your printer in a more economical way. So it sometimes makes sense to have a batch production and use it later. If you now look from the design side of the case, you see that, for example, assemblies that are made of different parts could be printed as one single part with additive manufacturing. So this is a very important topic in many applications, because so it reduces the cost of assembly. It also reduces the error in the assembly. And for example, if you imagine a heat exchanger, instead of producing it in different parts, then you need to assemble it, you need gaskets, and this could also introduce leakages in your system. But if you can print it in one single part, then you have less after production problems. So these parts that are designed as an assembly due to manufacturing constraints, because so many parts you cannot manufacture them in one assembly, because you need to manufacture them with single parts and then connect together. So this is what you can so you can do it with 3D printing without problems. Of course, not any assembly and not so any material technology combination is suitable for that, but this is what is available with additive manufacturing. Lightweighting is, of course, a very important topic if it comes to parts that are moving or in the transportation, which via 3D printing you can have shapes or produce shapes which have internal voids and holes which reduce the weight. So in the first site, it might look much costly to produce such shapes, but at the end of the day, it is decrease the cost of using these parts. So especially, for example, if you look at grippers for robots, it is the lighter the part, the less energy you need, or the less power you need to move the arm, and so it means that you save your operating costs on the robot. So how we can reduce the weight of the parts? Of course, there are different methods. So just for example, printing parts so hollow, not in solid form, which might not be possible with traditional manufacturing ways. Of course, you can have generative designs or topology optimization and all these, let's say, high-end design tools that then the production is only possible or almost only possible with additive manufacturing. You can, and I think this is the one of the most important aspects of additive manufacturing is to produce complex parts in one step. So this design freedom of additive manufacturing, especially if you have intricate geometries or hollow components or special geometries, for example, for the case of heat exchangers, that you can really increase the performance of your heat exchanger via 3D printing. So surfaces and geometries that are almost not available, not possible to produce traditionally. And of course, again, here is also the fact that you can have parts produced in one piece instead of in separate components and then assembled together. As I already mentioned, customization is an important aspect now in the production, especially if it is low volume production. For example, here you can see in the picture one of our customers that use 3D printing to mass customize the parts for the electric wheelchairs. So and this also helped. So additive manufacturing helps you to be faster in the ramp up times, check designs more quickly, and fit the part better to its function. If for example, so if you have special filters and you need special housing for that, then you can also design the housing based on simulation and print it and have it custom made for this kind of filter. So now let's say, okay, what are different parts that are interesting? So as I already said, so stuffs for spare parts for exterior furniture like food caps. These are really simple geometries, but the fact that they are not required in very high amount, especially after the end of the life of the product, so it makes it a promising part for 3D printing. Any kind of housing and cases, if it is a holder for a camera, for example, or a driller case. Also, the topic of seals and gaskets is very interesting, especially since that there are now many, for example, high temperature or chemical resistance materials available. You can also use 3D printed, for example, bearings or screws that are self-lubricants, or food-safe material are nowadays available, and these parts can be easily printed. For example, Miele, one of our customers, uses 3D printing to manufacture accessories for their household appliances and to offer that as a complement to their standard product portfolio. If you go to the metal parts, so the topic of different connectors, mounts, or components that are normally need to be welded together, but you can now print it in a single step, or applications where, so for example, high pressure hydraulic blocks that can be optimized for weight reduction. You can lower the weight of such a hydraulic block, for example, in this case by 80% than a traditionally manufactured block, and you also save a lot of material. So it's also another sustainability aspect on that. So just now to give you a use case that we had regarding remanufacturing of spare parts. One OEM needed some spare parts in a low volume amount for high, let's say, value machines that they have. And it is somehow the supplier doesn't provide these spare parts, these gears, because it's 30 years later, and the impact of these broken parts is relatively huge. So they lost a couple of thousands of euros per month and machine that it is not working. And of course, as this part was more than 30 years old, so there is no CAD files or design available. So you need to redesign that. So we had a look at this case. So the gears were from nylon material, and the OEM needed 250 parts per year. So the calculation that we did for injection molding of these gears with a PA66 material was that, so you need around 4,000 euro for injection molding tools, and around 1,000 euro setup costs that you have. Of course, you have to first create the design. So of course, it doesn't make any difference if you create these CAD files, if it is for injection molding or 3D printing, so the cost is the same. And after all this done, the production would be like 50 cents per parts. And this whole procedure took around 4 months until the OEM has its parts. So we did the same calculation for 3D printing, and we used ultra fuse PA material. So of course you don't need any molding tools for that. There is no cost. You have around 200 euro setup cost to get the right printing parameters and test prints, as I say. So making the design doesn't make any difference for which manufacturing method. and the production then would cost around €5 per piece. So just to have a look at only the production cost that sometimes the people do, is that you see that injection molding is way cheaper than 3D printing. However, you see also that the lead time by 3D printing is dramatically lower. So, but if you do the calculation on this total cost, and this is a relatively simple calculation, you can of course take also into account other costs, for example, like keeping the molds. You need the inventory, and these are the inventory costs for keeping the mold and all this stuff. So they are not here taken into account, but just doing a simple calculation, you see that there's a break-even point of around 1,000 parts, and which, if you have a volume of more than 1,000 parts, then injection molding would be the manufacturing way to go for that. But as I already mentioned, so the customer needed 250 parts, so it was clear that 3D printing is the production way to go. So I think I have give you a lot of information from different aspects. So now let's summarize it together and see, okay, we have now a checklist that before deciding on a part, so we take a look at this checklist to see, okay, does our part fulfill some of these criteria? Do we have long delivery time? Do we have high inventory cost, high minimum order quantities, of course, very high supplier dependency, long usage period if you need parts like spare parts after more than 15 years, low production volume, huge downtime costs because your parts are highly critical parts, long transportation routes. Do you have high production costs because of the complexity of the part, or do you have a huge usage of materials, so you want to reduce the weights to save money or have a better performance? Or as I mentioned, so do you have several different parts that you want to put in an assembly? If you, let's say, answer 2-3 of these questions with yes, then it makes sense to consider to switch to 3D printing. Of course, there are cases that even only one single yes would lead to the to going for 3D printing. But to go through all these questions for 3D for all your parts, it is a very exhausting task. So because it's quite often that you only have 2D drawings in no uniform quality, and you don't want also to waste your engineering hours to go through all these documents manually. And of course, you want to have some estimation of the expected efforts on the post-processing, because it's not only to 3D printed, but you want to have the part according to your drawings. That's where we can support you, for example, with one of our tools that we have, so-called R-scan tools that can go through the 2D technical drawings, extract the technical features on that, and digitalize it. And after it is digitalized, we can analyze it and give you a report on the 3D printability of the parts. Okay, on what size it, which material, on the post-processing, and you can also see the efforts which is required for the post-processing. So this module is, let's say, one of the modules that we have in our platform, which is the first step of screening the parts. After the parts are screened, then you can store them in a secure and encrypted form in the digital inventory. So you have your production files there, and then you can order via internal sales catalogs, and it will be then produced decentral around the world and completely encrypted. And of course, you can define so the quality measures that you need for your parts on the quality module that we have, that so that you can also track the quality of the parts through our platform. So I think I'm now coming to the end of my presentation, and I hope I could give you some information how to choose parts for your 3D printing challenges, let's say, and I'm looking forward to answer your questions.